In this video, we will learn about DevOps basics. In the end of the video, we will be able to describe what DevOps is. We can deploy Docker containers, describe orchestration and list container orchestration engine available for Linux. DevOps is the combination of cultural philosophies, practices, and tools that increase an organization's ability to deliver applications and services at higher speed than traditional software development methodologies. That means traditionally we use waterfall and complete each phase before moving on, while DevOps tries to incorporate lot of communication, tooling and essential software development methodologies in the process of how we build software. There are some DevOps goals like speed. We want to move at a higher rate so that we can innovate faster, adapt to change quicker, and grow more efficiently. We want rapid delivery, which means increase in frequency, pace of delivery, to innovate and improve the product faster. We want to have higher reliability to ensure the quality of application update and infrastructure changes so that we can reliably deliver at a more rapid pace while maintaining positive experience for the end user. Scale. We want to operate and manage infrastructure development process at scale. That means we want to scale up to whatever resource we require. Improve collaboration means we want to build more effective teams under our DevOps culture model. Emphasize ownership and accountability well. And lastly, security. We want to retain control and preserve compliance while the team moves faster. First, we will talk about virtual machines. Virtual machines is virtualization or emulation of a computer system. Virtual machines run a complete operating system including their own kernel. There are many virtual machine environment providers which include VMware, Xen, VirtualBox, Hyper-V, KVM, etc. Containers are isolated lightweight silo for running an application on the host operating system. They don't have their own system kernel. They build on top of the host operating system kernel. The host and container operating system must be the same. There are many common container providers, like for Linux we have LCX, LXD, CG Manager. Docker is the big player in the container providers. It runs on Linux and other operating systems. And Windows Server Container are another option. So, some benefits of container for DevOps are like these are less overhead. Containers are typically faster. They are more reproducible, so it is easier to reproduce an environment, which is often the hardest part of testing the software. It is hard for testing the software in different environments, different operating system, different third-party software installed. It's very confusing. Containers are immutable by default, which is essential for software testing. We will look into Docker. Docker is so big and we are going to use in testing. We can download the Docker from different links. As we know, containers can only run on their own operating system. But here Windows has an exception, as it is able to run Linux inside because Microsoft built WSL, Windows Subsystem for Linux, to run Linux inside Windows. So, you download and install Docker, and then you create a Docker file. This is simply a text script containing the instructions to build the Docker container image. The file name is Dockerfile. Dockerfile is step-by-step instructions. Docker provides a set of standard instructions to be used in Dockerfile, like from, copy, run, env, expose, cmd, just to name a few basic ones. Docker will build a Docker image automatically by reading these instructions from the Docker file. Docker Hub is a service provided by Docker for finding and sharing container images with your team. It is world's largest repository of container images with an array of content sources including container community developers, open source projects, and independent software vendors (ISV) building and distributing their code in containers. Users get access to free public repositories for storing and sharing images, or can choose a subscription plan for private repositories in Docker Hub. Here is a simple example Docker file. Here we are setting an image of operating system Ubuntu 18.04. We run an apt-get update and apt-get install for Python 3. We create a directory named anksoft. We copy test.py in this directory anksoft. We change the permissions and change the entry point to what gets run when the Docker file runs. That is running the Python script. There is also a Docker command line, so you can build an image with Docker build-image name. You can list the images with Docker images command and run an image using Docker run image name. Here we are going to think about orchestration, which is essentially mean continual software revision control. Continuous integration is quickly integrating app changes into main software. Continuous testing is our app modification undergo automated testing to avoid breaking applications. Continuous delivery is our software is delivered to customer on continual basis. Production environment must equal development environment. We will talk about containers to help us there. Environment modification must be controlled in a similar manner to software modifications. We test our new environments and add them to journal and maintain old environments so that we may go back to old environments and roll back. We have something called configuration management, which is non-hardware specs implemented into environment via automated code. We have policy as code, which is security measures, example, firewall ACLs, and authentication policies implemented into environment via script or automated code. Infrastructure as code is an umbrella term that include configuration management and policy as code, and we use all these to standardize our environment. When we go to deploy our application, we make sure that application and development environment are moved into production in a continual manner. This process is automated via infrastructure automation. Application production environment need monitoring and logging of various items such as software matrices, infrastructure resource uses, performance statistics. Monitoring also provides alerts, for example, failure and resource depletion events needed to be notified. Containers provide the following features: static environment, version control, replace, not update, high availability. When we go to code the infrastructure, we determine the required infrastructure. We document the required infrastructure. We automate configuration management, which is process of recording infrastructure as code settings. We build automation using the infrastructure as code data to automate the replacing and deployment of app containers. We provide revision control for infrastructure as code data, and finally we troubleshoot the infrastructure issues. When we come to automate infrastructure, it employs automated configuration management. It allows rollbacks of previous infrastructure if we find a problem. It eases troubleshooting infrastructure. Deployment is automated. There are two types of monitoring, agent versus agentless. Agent monitoring tool is orchestration utilities that require software to be installed in the app container being monitored. Agentless monitoring tools use orchestration utilities that do not require software to be installed in app container being monitored. Pre-existing tools within the container are utilized instead. There are some orchestration systems available like Kubernetes, which is designed by Google. It is an open source orchestration system. It is the platform for automating deployment, scaling the operations of application containers across cluster of hosts. It supported Docker containers in first version and later added the RKT container engine. Other orchestration tool is Docker Swarm. It is Docker Container Engine's orchestration tool. It creates a group of Docker containers known as cluster and monitors cluster health. It returns cluster to a desired state automatically. Thanks for watching and don't forget to like and subscribe.